Hello and welcome to the last lecture of this week 2 module. And I hope by now, although the lectures were telescoping into each other and were connected, by now you would have caught the basic idea of how the brain functions. The structure and the networks, and from there the behavior, structure, networks, then we jumped on to the microscopic synapse and all, and basic electricity. So, we will wind up with this week with a bit more understanding of how the brain functions. So, if you see the slide, we already asked this question. There is a possibility one, that the brain creates mind, and the second is that brain is an antenna, and there has been a philosophical debate on that in the past. But if you just compare, as I told you in the first lecture, the computer analogy is something, but this is just a gross difference. The computer is much faster, the units of brain are much more than computer, the connections are much more than the computer chips. The data which is used in computer is binary, is deterministic in the sense that we have programmed it, whereas the brain is a lot of graded signal processing happens, and there is a lot of stochastic random probable processes happening there. The hardware of the computer is somehow seems to be dissociated with the software, which you can load on the hardware. In the brain, it is like embodied. The structure decides the function, and function decides the structure. As we talked about network and synaptic formation, brain does not crash easily. So, if the brain crashes, although computer often crashes, we all know how they hang up. The moment you press one button for more than what is required, brain evolves. Computer has to be designed for evolution. Now, you can, if you are a believer, you can say maybe God designs, God has, it learns. The computer learning, although these days AI is talking of deep machine learning, where the machine itself picks up data and formulates further learning. But still, even that learning which goes on into computer is a programmed thing. It is not automatically it happens. The program for learning also has to be fed in. So, that type of training. Why I am talking about this? Because lot of this artificial intelligence and training, we will talk about this towards the last lectures, has happened because of the ideas which has come from the brain research. So, as we said, neurophysiology, neuroanatomy recorded, complex physical system, mathematical model, and over and above hunches, intuition. Like one of the intuition which happened, if you go back to the synapse which you remember, how does the chemical come from, whether they are neurotransmitter? It actually happened in the dream of Otto Lowitz. That is what he claimed, that he was struggling that between one synapse, one neuron which is a presynaptic to the postsynaptic, how did it go? And he says that one night he saw that there is a molecule which goes out, drips and goes here, and that gave him the idea of something, some chemical change going on between two neurons, and that was the discovery of acetylcholine. What makes the human brain human? Conscious, we all say conscious, we will talk about consciousness in different lecture, but it looks much like cat, rat, but we are conscious. Are they also conscious? Brain size, you human beings are attending, elephants are not attending this MOOC course. They can't log in and do an online certification. Dolphins are very intelligent, but in their own context. Whales are intelligent in their own context. Elephants are intelligent. So, does it make us more intelligent, or it is just that our intelligence is there in our own context and they are intelligent in their own context? Ratio of brain and body, we have talked about encephalization. So, this is just to revise, they are about intracortical within cortex neurons, and this is the size, any pair of cortical. So, between one neuron to the other neuron, if you have to look at it, any neuron can be connected to the other neuron with 2 or 3 synapses. That means, if you want to connect it A to say D, so there will be 3, maybe B, maybe C, 1 or 2, or if you have to go F, so maybe A gets connected to something to E and F. So, all neurons will be connected to each other within the cortex with 2 or 3 synapses. This theory has come from social networking theories, where each person is connected with 6 steps to the other person, if you make a network. So, obviously, what we are saying, and this is the inspiration for what graph theory, which tries to define neural networks. We will talk about that when it comes to it. It is not a linear network, because if you put it linearly, you will keep going round and round. The transit time, I have not talked about the transit time, is of the order of 300 millisecond. Consciousness, so you do not become conscious of anything unless, or if a stimulus is presented to you, and by the time you become conscious, already 200 to 500 milliseconds have passed. This is the wonder of the brain. Whatever is happening under 200 milliseconds is unconscious. So, there is a huge, so this whole debate of whether the mind is totally conscious or unconscious, actually neuroscience is tilting in favor of unconscious. We will discuss this in future lectures. So, there are feedback loops, which we will talk about. So, I showed you a slide where we are talking about investigating on various scales. So, these scales are natural. Although the brain is what you call a parallel distributed system, add modular to it, but still there are hierarchical interactions across spatial scales. So, if a signal comes, there may be few neurons which may be bringing the signal from external stimulus, but as they go inside the brain and try to present a composite image from the visual cortex to the thinking brain, the size increases. So, this is a hierarchy, right from few neurons to more neurons to cell assemblies to larger, and various part of cortex are. So, they are feedback loops, they are resonant interactions. Just remember these words, because before jumping to networks, I thought it will be good for you to have just few ideas. These are simple things to understand. The spatial scale in space, and this is the type of, we talked about macro columns. This is what I want you to pay attention to. Thalamocortical. Thalamus, if you remember, I told you, is a deep structure which is the relay center, where all stimulus go, all stimulus come from it, and thalamus and cortex in a reciprocal connection really control all this unifying binding thing, that whether you feel as a self, it controls consciousness, it controls your sleep wake at time, and basically rest and awake states. The third state is sleep. Sleep will come into picture later. So, this is managed by thalamocortical. The activities, the sensations which go in is between this thalamus and cortex. If you remember, thalamic inputs go up into layer 4 of those cortex. This is a comparative thing. This is what may be making us different from other animals, because they may have the same size, they may have enough neurons for them to survive, but the thalamocortical connections actually increases from rat to humans. This probably differentiates what we do and what we think and how we do it. So, this is the type of network which you see. These are all networks connecting the various areas of cortex all over the brain. So, if you look at this slide, this is I had showed you, again I am trying to revise the whole thing. There is a hierarchical dynamics if you compare with society, like there is an individual which grows on to neighborhood, to city, to nation, to global. We do not know whether this global is going on to some aliens or some other species of animals which may be more advanced than us, or maybe on some other planet, we really do not know. It may sound as fantasy, but lot of fantasies may actually later on prove on to be a fact. And if you think we are an experiment of nature, we may already be in a transit from going from amoeba to some other species. So, this query is for that unknown species. Compare it with how the brain works. There is a single thing called neuron. Some neurons get together to mini column. So, an individual's history is lost in global population. So, your own history may be very important for you, but if you look at the global population, it does not mean anything. It is the larger movement of global population which defines history. So, a single structure sacrifices itself, its own history for the larger history. Here module, macro column, neocortex. By the time the action happens in neocortex, a single neuron's contribution is minimized, because there are many of them, and this neocortex creates behavior. So, this is a multi-scale dynamic plastic system which keeps altering in conjunction with external influence, biochemistry, electrical activity, whether they are quantum fields or some other physics which we yet have to discover. How quantum steps in, I will tell you as and when it comes. So, how is it happening? We have talked about the chemistry, but when, as I said, you put your electrodes and you will find what are oscillations. Brain oscillations are very important. How does information carry from one part of the brain to the other? How does change of activity alter the electrical firing? No doubt chemistry is the switch, but and that switch can regulate how it fires, but that switch is left behind when we talk of the mode of transfers. Probably these oscillations of the brain are very important. They emerge from the interaction between cellular properties, that is the firing between neurons, and circuit properties. One single neuron connects to the other, the 2 to 10 to 100 to finally to 10 to the power 3 to 6 to 11. So, individual neurons oscillate. Individuals non-oscillating neuron that are hooked up in a specific network that produce oscillation. These may be very few cells which are connected by gap junctions. Gap junctions means two neurons are attached. There is a gap, there is some connecting material. These probably do not oscillate. There is a sort of more DC current which is going on between them. Here, and how does oscillation happen? Oscillation is this wave. But what causes? If you remember, the pyramidal cells which are on layer 5 are the neurons in cortex which send the signal out. So, that means they have to be excitatory, they will always excite whatever signal they get. So, if it is always an excitation, then the whole thing will rise like this, it will never come down, it is already firing. So, the game is what you call this interneurons. Between the neurons, there are certain neurons which are inhibitory. They are inhibitory obviously, because this chemical switch is what you call, they use a chemical called GABA. GABA is a general inhibitory neuron. Excitatory neuron is glutamate, and they have their receptors like NMDA, GABA receptors, GABA A, GABA B. So, this game between GABA and glutamate actually excites inhibitory neuron and excitatory. Why does it happen? Is it required? Because if it is all excitation, how will you differentiate between these differences of information? Ultimately, all this firing is about information transfer. You will not differentiate any change if the brain keeps perceiving the same set of waves. So, the inhibitory neurons, they entrain the excitatory cells, and that coordinates information, because if the 2-3 sets of information coming and they are all firing at the same frequency and same rate, it will become very monotonous. All your survival will become very dangerous. The trick is that small differentiation and later a integration of it, which keeps giving you the whole, I mean that is life actually, if you look at it. Translate the basic electrical activity into life, this is life. So, the interplay of inhibition and excitation creates oscillation, and any signal can be expressed as sine waves with its own frequency, amplitude and phase. Are these oscillations present only in human beings? But you look at it, phylogenetic preservation, right, in all mammals across species there are oscillations. The frequencies cluster around specific peaks. Vertebrates have more distributed, non-vertebrates have less distributed. So, the range in human beings is from 0.5 to 500 on power spectrum, and after doing a Fourier transform. What we are interested in raw EEG is 0.5 to say 30, that is delta to beta. Power density, I mean the amplitude is inversely proportional to frequency, is a basic physics law. The faster it is, the less time it gets to go up and down. That means, if it has to put energy and power, it goes very high, then it will take more time to come down to the negative state. So, amplitude is more, waves are slow, simple. This implies that the perturbations which are happening at slow frequency cause an energy dissipation at higher frequency. Slow oscillations modulate faster local events. Slightly hold on for a minute and try to understand this. If you look at it from the point of energy, and there is a firing which is going on, at higher amplitude, if there is a disturbance and if it comes down to faster frequency, so this gap, this energy which has really taken up to certain amplitude will have to dissipate somewhere, dissipate to other neurons in a form of a signal, right. What second law of thermodynamics, the way entropy grows into system, but that happens in a closed system. Brain in that sense is not a truly closed system, it is in interface with the environment. So, this energy dissipation, when it is transferred to the neighboring neurons, that will carry a signal. So, that is called a local event. The change from higher amplitude slow frequency to a lower amplitude fast frequency can be triggered by external stimuli, but this energy which is dissipated, actually it can't go anywhere, it has to fire other neurons. That means there will be a local disturbance there. Like if there are, I am just giving an example, if there are 5 neurons which are going on a high amplitude thing and some external event happens, these 5 go down to faster frequency. So, all this energy has to be passed on to the rest of the neighboring, maybe another 50 neurons. So, this signal which will go is a local event. Now, this local event can happen, cascade it, transfer information to other areas, but this is how the variation of oscillation through energy changes, which essentially means firing, catches the difference in signal. This local event which happens, now this 15 may fire 1500, the 1500 may fire 10 to the power 1 through their network. So, a local, and that is how it happens. Like, let me give you an example, very gross example, although there are multiple steps from this to actually what happens in the behavior. Maybe you are slowly meditating, your whole brain is in a slow, concentrating in a synchronized way. The brain normally is desynchronized, but in normal state you do not have a delta waves, that is abnormal, because brain does not get so synchronized ever. Suppose you are memorizing something, so you are already in 4 to 7 hertz and you are, which is carrying on the background of 40 hertz binding oscillation, over which you are memorizing 4 to 7 hertz suppose, and suddenly ceiling falls or the fan falls. Immediately what will happen? Then you have to act. To act, you have to get into the faster thing. Within that 30 millisecond to 100 millisecond period, your brain will get into activity. So, the frequency change would have happened is from 4 to 7, you will forget memorizing at that time, it will shift to beta. The amplitude, that energy will come down, frequency will go fast, but lot of neurons will get activated. So, a local event which is a falling externally or a sound of it triggers off this thing, those set of neurons which are learning immediately. You can't keep memorizing when the fan is falling on you. We all know that, the panic attack, the fear. So, this is the type of activity, the game which goes on in the brain all the time. I mean all the time till you die. So, this is what I have already told you. Brain networks oscillate and they are behavior dependent. We will talk about it. Beta is when a lot of activity is given to the brain, mathematics, maybe you are thinking and or you have problem solving. Theta is when you are memorizing in specific areas like hippocampus. We will mention hippocampus later on. But many of, now why I was saying thalamocortical, lot of this they arise from thalamocortical reentrant. Reentrant simply means feedback loops. This is the cortex, this is thalamus. Positive, negative, negative, positive. So, lot of this activity, and remember thalamus, if you remember, I talked about geniculate nucleus where visual thing is coming, auditory is coming, sensory is coming, which goes to parietal lobe. Now, you see how it is all integrated. All these informations finally go to cortex, whether you have to act on it or do whatever, this remains to be the trigger point. And taking all these disturbances, signals which are coming, this thalamus remains the pacemaker. So, lot of pacemakers are in thalamus, which give rise to this 40 hertz waves, alpha happens from cortex. So, this interplay. So, it is like maybe if you are sitting with your eyes closed, your brain is working at 13 hertz or 10 hertz, and suddenly some stimulus comes and your brain is uniting all different type of stimuli to give you a sense of self, right from your joints to touch to smell to vision to orientation into time and space, which I talked about, parieto-temporal lobe, and suddenly you have to do some activity. So, that 13 hertz wave will switch to beta or higher, or depending on what activity you are doing. 40 hertz may still be going on in background, but this 13 hertz will be inhibited and activity will increase. Now, suppose 13 hertz is happening here, thalamus is not firing, this is the predominant, but then when it happens thalamus suddenly switches the whole thing. So, the whole thing in the head becomes, this is the type of interplay which, so you can see this just a anatomical diagram. So, local there is something called mu rhythm. Mu rhythms are found in the center of the head just before movement. You do not normally see it on the raw EEG, but this is the type of loop which I wanted to tell you. There is a sensory input in thalamus, it goes on to cortex, it goes excites, this comes back to thalamus, right, and these are the type of reticular nucleus which you call, which keep you conscious also. So, now getting more complicated. Now, see the game. These are the pyramidal cells, the blue ones, different type of cells, these are the various complexes, right. just to show one of the systems, and this is the type of just corresponding waves. So, these are the ripples, these are theta wave which are happening. This is actually a memory thing. CA3 pyramidal cells are found in hippocampus, where which is the learning circuit. Any stimulus goes, the neurons keep firing there, and that is how short term memory is formed there. So, this theta wave is when you are learning, and there are various cells, pyramidal cells, basket cells, all these cells are throwing this theta wave when the learning process is going on, and gamma is the basic thing, binding thing which I said. So, this formulates the depth of modulation. So, on the background of gamma, these theta waves ride in spurts. Suppose a stimulus comes, one spurt, second, third. So, all the spikes which are coming give rise to this on the background of gamma. And it is important why gamma is there, because gamma I told you possibly is the binding oscillation. Suppose you remove the binding oscillation, whatever stimulus is coming may be memorized, but how will it get integrated? So, get integrated, this wave is right, the spikes are riding on the already existing template, and they finally get integrated to form the memory, because otherwise what will happen, that all pieces of memory will be separate and you cannot recall the whole thing. How will you recall the whole thing? If I tell you rows, you will see so many things, but if everything of rows has gone separately and it has not been integrated with the already existing background self, next time I talk rows, you will tell a thorn, you will still not visualize. So, to complete that, this type of network has evolved. So, you see this internal and external environment, isocortex, entorhinal, and these are different type of cells which are formed, but the whole system goes into this forming acetylcholine and GABA. GABA is inhibitory, acetylcholine is the neuron, is the chemical which actually is most important for memory. So, these are type of black swan is a theory brought out by Nassim Taleb, who says that maybe if you take a general account of events happening, that may not be, that may give you an idea, but it is actually the rare event and its impact which gives you the progress of a system. So, neuromodulation. So, all this firing is, again as I said, what are the important factors? Signal to noise ratio. So, neuromodulators are the neurochemicals, there are some intrinsic and there are some extrinsic, switching between one frequency set to other. As I said, burst or single spike, oscillations, these are all circuit properties. So, single neuron, when they get into neuronal assembly, they actually start developing circuit properties. So, switching between tasks, you can switching between frequencies. So, these modulators can alter the intrinsic property. You can see the type of waves and the alterations which happen with chemicals. So, three type of stuff which happens, one which happens with neighboring columns, you remember that macro columns, which produce high frequency components, which was a local disturbance or a local event. That local event, change of frequency, high frequency always happens in the localized way, because otherwise it will not get triggered anywhere, it has to happen somewhere to start. Intermediate or regional oscillations happen between larger areas, which produce alpha and beta and all that. When the activity starts high frequency, then it has to spread. But if you take the whole brain synchronization, when the whole brain is working, then you get to a slow movement. So, high frequency can happen in localized area with the underlying high frequency binding thing, which keeps binding everything. But when the whole brain gets into a similar type of oscillation, it is the slower frequency, because they are high amplitude, slow waves. So, why is it important? Because input signaling, linking neurons, synaptic plasticity, temporal representation. So, we will end at this, and next week we will start exploring the networks. Thank you.